Today our topic is small concept in solution, or the different methods to express the concentrations of solutions. What is a solution? A solution is a homogeneous mixture of two or more components. Homogeneous mixture of two or more components. If a solution contains two components, we will call it as a binary solution. If a solution contains two components, we can call it as a binary solution. In a solution, there is a solvent and a solute, sometimes more than one solute. There will be one solvent, one or more than one solute. But in binary solution, one solvent and one solute. To express the concentrations, we have different methods. The first one is mass percent. What is mass percent? It can be represented using an equation. Mass percent is equal to mass of solute divided by mass of solution into 100. Mass of solute divided by mass of solution into 100. What is meant by mass of solution? This is the sum of the masses of solute and solvent. Sum of the masses of solute and solvent. That is mass of solution. Okay, when we solve a problem, it will be more clear to you. It is the question. A solution is prepared by dissolving 50 gram of NaCl in 150 gram of water. Calculate its mass fraction and mass percentage. Here you can see a new term, mass fraction. What is mass fraction? It is equal to mass of solute divided by mass of solution. That means mass of solute divided by mass of solute plus mass of solvent. That is mass fraction. So mass fraction into 100, mass percentage. Okay, here we can first find out mass fraction. Mass fraction is equal to mass of solute divided by mass of solution. What is mass of solute? 50 gram. Mass of solution 50 plus 150 equal to 200, equal to 0.25. Now what is mass percent? Mass fraction into 100, 0.25 into 100. That is equal to 25. 25 is the answer. Another important term that we are using to express the concentration is parts per million, ppm. Especially to express very small concentrations, we are using this term parts per million. The hardness of water is expressed in parts per million. And the concentration of fluoride, chloride, different metals, lead, etc. are given in parts per million. Drinking water standard, that is clearly given in parts per million. So it is an important term to represent the concentration of very dilute solutions. What is parts per million? Mass fraction into 10 raised to 6, that is parts per million. Parts per million is equal to mass fraction into 10 raised to 6. Mass fraction, mass of solute divided by total mass of solution. Mass of solute plus mass of solvent. Okay, we can solve a problem. A sample of water contains 40 milligram, not 40 gram, 40 milligram calcium chloride per 1000 gram of water. Calculate its concentration in ppm. So here what is mass of solute? 40 milligram, that is equal to 14 to 10 raised to minus 3 gram. 14 to 10 raised to minus 3 gram or 0.04 gram. 0.04 gram or 14 to 10 raised to minus 3 gram. Mass of solvent 1000 gram. So mass of solution 1000 plus 0.04. Approximately we can take it as 1000. Now substitute the values in the equation. Mass fraction is equal to mass of solute divided by total mass in the solution. Okay, mass fraction, mass of solute 14 raised to minus 3 divided by 1000, that is equal to 40 into 10 raised to minus 6 40 into 10 raised to minus 6. Now what is parts per million? Mass fraction into 10 raised to 6. Mass fraction into 10 raised to 6. That is 40 into 10 raised to minus 6 into 10 raised to 6 equal to 40. So 40 is the answer. Another important term which is using to represent the concentration of solution is mole fraction. Mole fraction. What is mole fraction? Usually represented as X. Mole fraction of component A, XA, is equal to number of moles of A divided by number of moles of solution. Mole fraction of component A, XA, is equal to number of moles of component A divided by number of moles of solution. That means total number of moles in the solution. If Na represent number of moles of A and Nb represent number of moles of B, then mole fraction XA is equal to Na divided by Na plus Nb. Similarly, mole fraction of B is equal to number of moles of B divided by number of moles of solution. Mole fraction of B, Xb, is equal to Nb divided by Na plus Nb. If it is a binary solution, there will be only two components, A and B. Now, can you add XA plus XB, mole fraction of component A plus mole fraction of component B? What will you get? The value will be 1. That is given here. In a solution, sum of mole fractions of all components equal to 1. If there are two components, sum of mole fraction of these two components equal to 1. So you can check your calculation whether it is correct or not. After calculating the mole fraction of each component, add the mole fractions, and if you are getting 1, your answer is correct. Now we can see a problem. A solution is prepared by mixing 20 gram methanol and 30 gram water. Calculate its mole fraction. Methanol, what is methanol? CH3OH, that is methanol. So 20 gram methanol is mixed with 30 gram water. Thus a solution is prepared. You have to find out mole fraction. Mole fraction of methanol and mole fraction of water in the solution. First we can see mole fraction of component A. A usually represents solvent. Which is the solvent here? Water. Mole fraction of A is equal to number of moles of A is equal to W by M, given mass divided by molecular mass. What is mass of water? 30. 30 divided by molecular mass, 18, equal to 1.67. Number of moles of B, mass of B, 20, divided by molecular mass, 32. C12, H4, 12 plus 4, 16, or 16. 16 plus 16, 32. So number of moles of B is equal to 20 by 32 equal to 0.625. So we got Na and Nb now. Na 1.67, Nb 0.625. Now simply substitute these values in the equation and you will get the answer. So mole fraction of A, that is represented as XA. XA is equal to number of moles of A divided by total number of moles. That means Na plus Nb. Na divided by Na plus Nb. That is equal to 1.67 divided by 1.67 plus 0.625 is equal to 0.728. Okay, now mole fraction of B. Mole fraction of B is equal to Nb divided by Na plus Nb. That is 0.625 divided by 1.67 plus 0.625 equal to 0.272. Okay, next, another important term to represent the concentration is molality. What is molality? Molality is the number of moles of solute present per kilogram of solvent. Number of moles of solute divided by mass of solvent in kilogram per kilogram of solvent. Mass of solvent in kilogram. Can represent it using an equation. Molality M is equal to WB into 1000 divided by MB into WA. WB is the mass of solute, MB molar mass of solute, WA is the mass of solvent. Okay, we can solve a problem. Calculate molality of a solution prepared by dissolving 20 gram NaOH in 200 gram water. Here, what are the data given? WB, is it given? Yes, 20 gram. WB is equal to 20 gram, WA 200 gram, and MB molecular mass of NaOH 23 plus 16 plus 1, 40. MB is equal to 40. Now, the equation molality is equal to WB into 1000 divided by MB into WA. Substitute correctly. WB 20 into 1000 divided by MB 40 into WA 200. That is equal to 2.5. A simple calculation, very easy. Another important term to represent the concentration of solution is molarity. Here MOLA, LITY, molality, and the next one is molarity, MOLA, RITY, molarity. Here you can see molarity, MOLA, RITY. Molarity is number of moles of solute present per liter of solution. Number of moles of solute present per liter of solution. That is molarity. So what is molarity? Molarity is number of moles of solute present per liter of solution. Number of moles of solute present per liter of solution. That is molarity. What was molality? Number of moles of solute present per kilogram of solvent. So molarity can be represented as, how can you represent molarity? Number of moles of solute divided by volume of solution in liter. Number of moles of solute divided by volume of solution in liter. That is molarity. So as in the previous case, we can write it as an equation. Equation is equal to molarity, capital M. Molarity is represented using capital M. Molarity, capital M, is equal to number of moles of solute, WB by MB. Number of moles of solute, WB by MB, into 1000 divided by V. Number of moles of solute, WB by MB into 1000 by V. That is molarity. Did you understand the equation? WB into 1000 divided by MB into V, where V is the volume of solution. V is the volume of solution in liter, sorry, in ml. In order to convert ml into liter, we are using this 1000 here. In order to convert ml into liter, we are using this 1000 here. Here you can see 1000. In the previous equation also you may be confused. Molality, what is the equation? WB into 1000 divided by MB into WA. So usually in problems you will get the mass in gram. In order to convert gram to kilogram, you are using the 1000 there. Similarly here, in order to convert ml to liter, we are using this 1000 here. To convert ml to liter. How can you convert ml to liter? By dividing into the 1000. So V by 1000, that can be written as WB into 1000 by MB into V. That is the equation to find out molarity of a solution. Okay, now a question. Calculate the molarity of a solution prepared by dissolving 14.9 gram of H2SO4 in water to form 1500 ml solution. So here WB is equal to 49 gram, V 1500 ml. That is molar mass of H2SO4, 98. Okay, molarity is equal to WB into 1000 divided by MB into V. 49 into 1000 divided by 98 into 500, that is equal to 0.75. So these are the different terms that we are using to express the concentration. Now homework for you. Commercially available concentrated HCl acid contains 38% HCl by mass. The density of the solution is 1.19 gram per centimeter cube. Calculate A, molality, and B, molarity of the solution. How to find out molality and molarity? And you know the equations to find out molality and molarity. This equation for molality, WB by MB into 1000 by WA. So we have to find out WB, MB, and WA. 38% means 38 gram HCl in 100 gram solution. This is a hint for the solution. So WB is equal to 38 gram. MB, HCl 36.5. WA, 100 minus mass of solute. Total mass is 100. So 100 minus mass of solute. What is the mass of solute? 38. So 100 minus 38 is equal to 62. And we require V to calculate molarity. How will you find out V? We know density is equal to mass by volume. Therefore, volume is equal to mass by density. Mass is 100 gram, mass of solution. Density 1.19. So 100 divided by 1.19 is equal to 84.03 ml. So all the data are now clear. Now simply write the equation, substitute, and calculate. Second one, how many grams of NaOH should be dissolved to make 100 centimeter cube of 0.15 molar NaOH solution? We have the equation molarity is equal to WB by MB into 1000 by V. Here, what is given? Molarity is given. 0.15 is equal to how many grams? WB is not given. Divided by MB into 1000 by V. Substitute the known values and the only unknown value is WB. You can find out it. Okay, by this the chapter is over. Do the homework, submit the assignment in time, and study well.